Hi. Feel very honoured to be stood in a room full of civil engineers and structural engineers. I'm a control systems engineer, so thank you for letting me speak here. We'll be talking a little bit today about some research we are conducting. This is very much the background and not the evidence. One of my colleagues, Yaya, who's in the audience today, will be one of the driving forces for the evidence, and hopefully we'll be bringing this back to many conferences to show what we've learned. As myself, I'm Asset Standards and Engineering MICA, Mechanical Electrical Instrumentation, Control and Automation from the Environment Agency, and I set the policy, process and strategy for our mechanical electrical assets, of which we have 3,500 assets with 38,000 pieces of individual equipment amongst them. How do we look after them? Maintenance takes place on set time periods. Our PPM are preset 3, 6, 9, 12, 24 months. We do have some risk-based approach to some of these assets, where if we feel it's not long enough, we'll do it more frequently, but we have very little evidence showing us what's actually happening. So what we're looking to do, data gathering by intelligent sensors to help us predict when maintenance is required and prevent unexpected equipment failure. Our assets protect, I think it's around about 5.5 million households in the UK, around about £60 billion worth of national infrastructure. We are not considered critical national infrastructure ourselves, but we protect everything that is critical national infrastructure. But that's just a quirk of the way the Cabinet Office views what we're doing. The way we started this, our cars are very intelligent now, and as I was explaining this to the Environment Agency board, this was the one thing that actually pricked up the ears. Your car tells you when something's going wrong. It tells you when you need a new wiper blade, you need some air in the tyres, you need to refuel, etc. When I first got my car, you waited for something to break, or you took it for a service and then it broke. So now the car tells you exactly when you need to give it some attention. It's constantly monitoring, and it's looking at what's going on. So gathered data is obviously the right way to go for this. The evolution, I've used this to explain this. When I joined the industry pre-1990, it was the age of control systems. Everything was becoming automated. We put things in. We've made the processes more efficient. Downtime was expensive even then, and the control systems really improved that situation. The digital age has come along, adoption of control systems, again, to further improve process efficiency, moving from reactive to preventative maintenance, and then again on to the thing that we're looking for, predictive maintenance. We've seen, the evolution of the Internet of Things, energy efficient product. All of this, very much the ethos behind what the Environment Agency is trying to do. Someone touched on this morning carbon, a very interesting thing there. What is the cost of carbon to a project? To us, a breakdown costs us carbon, because we have to have people going out there, we have to have emergency equipment behind it. It's a very carbon intensive process in a breakdown, and that's without actually having to bring new equipment in. We're in the age of analytics. That's the way we're viewing it now. Focus on total cost of ownership, whole life cost. I think somebody touched on that this morning. It's not the cost of a component, but it's the cost of running it. So it's the energy cost together with the maintenance cost over the lifetime. So the better we can get with sensor-driven decision analytics, the longer we can have an effective lifetime. We can sweat the assets much longer than we ever used to do. So we're looking at the practical application of an intelligent maintenance system. So we've got interest in tools and systems that mean we can spend our maintenance budgets more effectively. intelligence systems that preempt failures. That's what we need. We need somebody to tell us something. So we've got challenges, which I'll go into as to how we can adopt these systems, because it's not simple. We have very low utilization. I can take you to a pumping station, not very far from here, that ran 25 hours last year. We've got other pumping stations that running about 70% utilization. So there's probably not one size that fits all, but there's going to be a break point as to where we can use this technology effectively, and where, in fact, we'll just have to continue on with a strategy of planned maintenance. Many different types of site. We've got over 300 pumping stations, and they're pretty much all different. The way the agency has evolved over the years out of the water authorities in the 1990s when we were formed meant that we inherited pumping stations from Yorkshire Water, Anglian Water, Severn Trent, and they all had completely different design philosophy, different strategies behind them. The equipment we've got, we're starting to get better in having equipment at one asset that matches another asset, because when I started in the Environment Agency about 11 years ago, we had 4 pumping stations that had similar pumps in across the country. They all had totally different pipework arrangement, totally different types of pumps, totally different types of pumping. We had different operating philosophies, and in fact we had a very, very different take on maintenance. We used to run a strategy that was run to failure. Didn't really suit what we were doing. Failure was generally in the middle of a flood incident, and houses that were the other side of pumping stations were invariably subject to significant problems. We have significant telemetry and data gathering limitations, which we're taking up now. The Chancellor is hopefully approving the budgets to improve our telemetry system significantly. The last major systems were put in over 25 years ago. We've had a lack of in-house expertise. We haven't got in-house maintenance engineers now. It's a significant problem for us. When the agency was rationalised in 2003, all of our field M&E experience disappeared from the agency. So 96% of our maintenance is contracted out. So there's a consistency of the person who comes to your pumping station to look at it is completely gone there. The other thing, when we looked at IoT systems in the past, everything's been extremely different. So we need to make the system intelligent, and there's the first picture that will test you out. That's not in fact a pumping station, that's a sluice, and my colleagues put the wrong photo in there, but never mind. But embedding sensors in pumping stations, we've got to do that. We've got to put enough intelligence around there to gather the data to tell us something meaningful. We've then got to use the data, develop the algorithms, which actually tell us what's going on. We've got to have better automatic planning for replacement of assets, so we will be able to tell from the algorithms the actual wear patterns. When do we need to start planning for replacement? Now, it's very much an engineering opinion on a lot of this, and we've had very many experienced engineers in the agency, many engineers who've done over 30 years service. That experience is now lost, and our new generation don't have the benefit of that behind them. Automatic analysis is the key to this, but as it says there, it requires an awful lot of learning and an awful lot of time. So how are we going to do it? Instrumentation, there's lots of it about there. It's just a few examples of it. The most interesting one there for us potentially could be noise. We've seen this done before. I've seen this done on an inlet works in my days pre the Environment Agency for one of the water companies. When they looked at noise analysis on a sewage treatment inlet works, the main sewage works in Edinburgh, they reduced breakdowns by a factor of 50 by noise analysis. That saved them in the order, I believe, in the order of £250,000 a year in unplanned breakdown. That, in fact, was achieved by a novel system which was taking on an operator to walk around and listen and look and understand that. So how can we replicate this? How can we replicate the ear better to understand the patterns that are happening inside the pumps? Data analysis, we know there will be anomalies in what sensors are picking up. We've seen much of that today, and I'm sure we'll continue to see much of that, but degradation is the issue. Gradual changes, and the gradual changes that are going to happen when we're not running our units. If there's a period of dry weather for maybe 6-8 months, which we've seen many pumping stations actually not have any work to do for 11-12 months. How are we going to understand the degradation? How are we going to understand what's going on inside that unit without opening up? Taking the units out and opening them up is very expensive. The UK taxpayer doesn't like to pay for it, so my budgets have shrunk by 50% in 11 years. So how can I do this more efficiently? The link there to our CMMS, our maintenance management system, what we want is a sensor to tell us something, but linked to CMMS, send it straight to our contractor, and the first I know about the issue is when I get an invoice across my desk. So I can sit with my feet up for the rest of my career and let this work for me. That was what I told the board, and the board said, if you can do that, yeah, you can have that job. So the aim is the take-up of new sensing technologies, predictive analytical techniques, so we can look at how we can develop this strategy. As I say, the strategy of proactive maintenance we want to adopt, but we're not going to be able to adopt it everywhere. We're still going to have to do some PPM. We're still going to have to do some run to breakdown, but it's how this strategy will save us money, and we believe there's 20 to 30% savings in our strategies if we do this effectively. So we're doing a proof of concept and pilots. We're on that at the moment. Unfortunately, with the EU tendering process has been a little bit cumbersome, and we've had one slight halt so far, but we are tendering again to look at this, to actually explore the challenges in depth. We're looking at data collection, sensor collection, how can it work together, a design, an implementation, and then a period of probably 18 months of data collection and correlation to see if we were right. So as I'm saying, we're looking at the contractor to develop algorithms for us, see if we can understand the remaining useful life as an indicator of what's going on in there. We hopefully will be able to develop these algorithms in a simple form, red, amber, green type analytical to tell our operators when they need to do something. But we need time to change and time to learn before we can operate, before we can unlock the operational efficiency savings, which is our motivator to embrace the technology. We'll have better, more effective asset management. We'll be able to plan better for replacement. Lower whole life cost, maintenance energy call-outs. It's a huge remit for us. Reduction in our breakdowns. We don't want things to break down. You don't want things to break down if you live near a flood defence or live in a low-lying area. And carbon saving. It's what we're trying to do at the moment. We've reduced our carbon footprint by 40%. My target is to drop that by another 10% in the next 3 years. And then the strategic context of this, 340 pumping stations, 12 million a year annually on maintenance, and 35% of carbon emissions are from our operation. That 12 million, we're looking to drive that down to potentially in the order of 10 million. And carbon emissions, we believe we can shave another 5 to 8% off just by efficient operation of assets. Thank you.